In this video, we will try to calculate the marginal rate of substitution, that is MRS, of a Cobb-Douglas utility function. Let us do this with the help of an example. We are assuming that there are two goods which are hamburger and chicken. So if we have these two goods, we can develop a Cobb-Douglas utility function from it, and when we do, we usually follow this standard form which is mentioned here. This is the standard form of the Cobb-Douglas utility function, where small a is a positive value, and here we are assuming that its value is 0.75. so if it is 0.75, we can write its value here as we have written here, and it will be 1 minus a with the other variable that is in its power, and the first good is hamburger and the other good is chicken, as it is already mentioned here. So we have customized the Cobb-Douglas utility function here contrarily to the standard form which is given here, where x and y are used. Here we are using h and c for hamburgers and chickens respectively. So now we use the acronyms of the variables, that is h and c. This 1 minus 0.75 becomes 0.25, and now the Cobb-Douglas utility function, which is customized to our given numerical, is now finalized. Now we have to calculate the marginal rate of substitution between h and c, and for that we have this formula that we have been studying before, that is the differential of the second commodity, that is c, and the differential of the first commodity, that is h. So the ratio of the differentials we can calculate, or we can go for the marginal utilities primarily of the first commodity and then the second commodity, and then we'll take their ratio, and we'll put a negative sign here as well to show the negative slope of the indifference curve. So now we calculate the marginal utility of h, which is easy to calculate because we will use the marginal the marginal effect using the partial derivative. In this case, we are going to differentiate with respect to h. So we are going to apply the power rule here, and c will be treated as a constant, and that's why you can see it outside the derivative solution, and 0.7 is actually the part of the power rule, and this would be the remaining term generated with the power rule. Now you can see simple calculation of it. I have reorganized it by placing h in the denominator because its power will become adjacent to the power of c, and then we can write them collectively, making it a more consolidated response of marginal utility with respect to hamburgers. Now the same process can be done with the utility function in consultation with the chicken variable, and here you can see the partial differentiation with is with respect to the variable c, that is chicken. So the same power rule process will be used, and h term will be considered as a constant. That's why you can see it outside the given expression. Here the power rule is being applied here as well as here. Now we have the final answer of it. It is consolidated just like we did with the marginal utility with respect to h. So now it is marginal utility with respect to c, that is chicken. Now the formula is to be used, where we are going to substitute both of these values, that is marginal utility with respect to h and then with respect to c. So in the next step you can see the substitution. This is MUH and this is the value of MUC. The simplification process will take place, and we will use simple algebra and adjustments to make it look a coherent result, and this is the coherent result, minus 3 into c over h. Now we have the values of h and c as we were given in the statement of this question. We can come to it. This is the question, that is 8 pounds of hamburger and 4 pounds of chicken. So we can use these values of hamburger and chicken in this numerical, and we can come up with the numerical answer of this MRS. As you can see, now we have used H and C, their numerical values, not just their symbols, and once we do this we get the final answer, which is minus 1.5, which is less than 0. It means that we have a negative slope of indifference curve, which is quite a bit expected from the theoretical knowledge that we have regarding the indifference curve, and it shows the diminishing marginal utility. And then we have the MRS, its interpretation. It means that the individual has to give up 1.5 pounds of hamburger for every additional pound of chicken that he may want to consume. So this was the interpretation of the marginal rate of substitution that we have calculated by using the given information borrowed from this source, and this is how we do the MRS analysis of a Cobb-Douglas utility function. Thank you.